in this problem, we want to synthesize this para-disubstituted benzene, and we have a nitrile group and this butyl chain attached. So we know that in order to make this benzene carbon bond, we're going to want to use a Friedel-Crafts reaction. And the nitrile group will add through a diazonium ion reaction. Okay, so what we'll do is we'll first get the NH2 group installed at this position where the nitrile will end up, and then from there we'll work through the chemistry to figure out how to get this butyl group attached. And in that process, since we do need just this para-selectivity, we will have to figure out a way to sort of hinder those ortho positions for the reaction. So what we'll start with is we'll start with benzene. And we need to get our NH2 group installed at this position, so our chemistry for that is going to be nitration. And then we'll get that nitro group and reduce that to an NH2 group. And we'll just do that with hydrogen and palladium. Okay, so we have our NH2 group installed, and we do know that this is an ortho para director, but we have a couple of problems here that we have to consider. One is that you cannot do Friedel-Crafts with an NH2. The second problem is that the NH2 directs to both the ortho positions and the para position. So if we tried to install something at this point, you would get installation at all three groups. So from here, what we want to do is actually put a bulky group onto that nitrogen, and that's going to help us out. So the bulky group we're going to use, we'll use acetic anhydride, and that will put this acetyl group onto the nitrogen, giving us the bulky amide. So a couple of things to consider here. This amide group is bulky, so it blocks out these ortho positions, which is something we want. Also, even though we still have this nitrogen, this group is fine with Friedel-Crafts. So from here, we're ready to install our desired group at this para position. We now have our bulky group. We're ready to install our group at the para position, which is a butyl group. And a common mistake that people commonly want to make, if we want to install a butyl group, they'll think, well, let's just do a Friedel-Crafts alkylation. And that will put this butyl group on the ring. Okay, but remember, we have the issues of carbocation rearrangement. So if we think about this as going through this carbocation, remember that this primary carbocation will rearrange to a secondary carbocation. And we'll end up getting the bond at that position, which isn't what we want. So a better route is going to be, instead of using this Friedel-Crafts alkylation chemistry, we'll use Friedel-Crafts acylation chemistry. We still need a 4-carbon chain, but instead of the alkyl group, we'll use this acyl chloride and the AlCl3. Okay, now from this, what we're going to get still have our amide group. Now we've installed this 4-carbon acyl group. So we have our 2 positions functionalized. Now we just need to do some functional group interconversions to get these to our final product. So the first thing I'm going to do is I'm going to go ahead and deal with this amide and get that converted to the nitrile. We'll do hydrolysis. That gives us the NH2. From there, we can do the diazonium chemistry. NaNO2 and HCl. And since we want to convert that diazonium to a cyanide group, we'll use copper cyanide. And that will turn that into the CN. Okay, so there's our CN group. Now we still have this acyl group, but remember we just want the 4-carbon chain. So what we need to do is we need to reduce off this carbonyl. Best way to go about that, we'll use the Wolff-Kishner reduction. And that will reduce this just down to the CH2 group. And that's our final product.